All right, let's make sure we're ready for this test. We'll go through this practice test here. First question, no surprise, derive the quadratic formula by completing the square. So here's what we're going to do on this one. I'll zoom in just a tad so we've got plenty of room. First thing I want to do is save room to complete the square. So I'm going to move that c to the other side. I'm going to subtract c from both sides. So I get ax squared plus bx, and then over here, again, saving place there, I have a minus c on the other side. Then I'm only going to complete the square with a plain old x squared. So I'm going to divide every term on both sides by an a. So those are going to cancel off, and I'm going to get an x squared, and then I have a plus b over ax. And then on the other side, I've got the minus c over a. And then we're going to take half that middle coefficient. So if I take 1/2 of b over a, I get b over 2a. And I'm going to hang on to that for just a second, and I'm going to square that. I'm going to change colors here because when I add this, I'm physically changing both sides. So I'm adding a b squared over 4a squared, because if I square b, I get b squared. Square 2a, I get 4a squared. So I'm going to add that to both sides. So 4a squared right there. And then I get this nice easy part over here. This is just a perfect square of x, that variable, and then b over 2a, quantity squared. And then let's see what I have here. I need to get a common denominator. I've got an a and I've got a 4a squared here. So I need a 4 on this one, and I need another a. So I'm going to multiply the top and bottom by a 4a. So here's what I get. I would have a common denominator of 4a squared, and then the numerator, if I want to write it this way, I'd write a minus 4, and I'll do an ac plus a b squared. But we normally write that squared term first, and it's positive, so that kind of makes it look nice. So we've got a b squared minus 4ac. And then I'm going to take the square root of both sides. So once I take the square root of both sides, here's what I get. I get x plus b over 2a. And then on the other side, I've got a plus or minus. And then I'm going to have a big square root on the top, and it's going to be b squared minus 4ac. And on the bottom, I'll go ahead and write this for the time being. This is 4a squared. So I get x plus b over 2a. And then on this side, I get plus or minus. I'll leave this ugliness up here because I can't simplify this. I can't take the square root of b squared. I can't just take the square root of each one of these terms, and I can't factor that at all. I don't have any pairs of factors that I can take out. So I'm left with a b squared minus 4ac. And then on the bottom, square root of 4 is 2, and square root of a squared is a. So we've got this common denominator. All I need to do is get them on the same side. So I'm going to subtract b over 2a here, subtract b over 2a here. So this is what I get. I get negative b over 2a, and then that's going to be plus or minus. There's that big square root. Okay, and I'm probably showing more work than is absolutely necessary, but that's okay. So here's what I finish off with. I can write this as one single fraction because I have a common denominator, so there's going to be a 2a. I've got this negative b, and then plus or minus this big square root. So this is b squared minus 4ac. And that right there is the quadratic formula. So we just derived that. Okay, I'm going to come down here and take a look at the next few. We want to simplify each one of these complex operations or operations with complex numbers. So here's what I'm going to do on this one. I'm going to have 7 minus 6i, and then I'm subtracting each one of those. So this is a minus 5, and then this is plus 6i. So the two of those are going to cancel each other out. We end up with 7 minus 5, so that's just a 2. The next one is an addition problem, so that's pretty easy. I'm just going to write 7 plus 2i plus 2 plus 8i. I've got these real numbers that I can put together, so I get a 9. And then I've got the 2i and the 8i, so this is going to be a plus 10i, and we're done there. This next one, what we want to do is we want to simplify each one of these separately. So this is going to be, let's see, that's a 6 and a 7, a 2 and a 3. So I can't take anything out. So what I'm going to do is I'm just going to write it this way. I'm going to write I radical 42 and I radical 6. And then I'm going to do an I squared. And then I'm going to break this down. And this is going to be a 7 times a 6 times the 6 from over there. And then there's a pair of factors. So I've got a pair of 6. So this is going to be 6I squared radical 7. And remember, I squared counts as a negative 1. So this is going to be 6 times negative 1 times radical 7. So this is negative 6 radical 7. And we're going to circle that or put a box around it, and we got our answer there. Now we're going to start doing some multiplication problems here. So I'm going to multiply here and here. That's going to be 25 and then plus 30i. Multiply here and here. So that's going to be a minus 30i and then minus 36i squared. These are opposites from each other, so they cancel each other out. So I've got a 25, and then I squared counts as a negative 1. So this is, if I've got negative 36i squared, that's going to count as a plus 36. So that means I can add the two of those together, and I end up with 61. So there's that one. We'll go ahead and multiply here and here, here and here. So I get a 12. I get a plus 8i, I get a minus 3i, and then I get a minus 2i squared. So immediately we're going to take care of this one. A minus 2i squared counts as a plus 2. So I've got some like terms, some whole numbers, some constants. So I get a 14, and then I get a plus 5i. So there's the next one. And then 38, I to the 38. Okay, so this repeats every 4. So remember, I is the square root of negative 1. I squared is negative 1. I to the cube, or I to the third is going to be negative I. And I to the fourth is 1. And then it just repeats. So there's several different ways you can do this. You can think of each one of these as, we could break it into pairs of i's and stuff like that. Or we can just take 38 and divide it by 4. That's a 9 with a remainder of 2. So what that means is this is exactly the same. I to the 38th is exactly the same as I squared, and I squared is negative 1. So that's it. There's our answer. Okay, lots of different ways to think your way through that. This one right here, we're going to need to multiply by the conjugate. So you might want to think about what the conjugate would be in this case. I'm going to zoom in on this one so we've got a little bit more space and room. So we're going to multiply by the conjugate of 6 plus 4i. Well, that's going to be 6 minus 4i. So 6 minus 4i. So in the denominator, we end up with this. This is going to be a 36. If I multiply here, that's a minus 24i. Multiply here, that's going to be plus 24i. And if I multiply there, that's a minus 16i squared. In the numerator, I get an 18, and then this is going to be a minus 12i. This is always going to happen with conjugates. Those middle ones are always going to cancel out. So if you didn't want to write them, I suppose you wouldn't have to. Negative 16i squared, that's going to count as plus 16. So those add together to be a 52. So here's what I've got. 52, 18 minus 12i on the top. And then if you can simplify this, we probably ought to break this up a little bit because we notice that all those have, they're all even numbers. So I'm going to do 18 over 52 minus 12i over 52. And then let's see, 2 goes in there. So this would be a 9 over 26, but 4 goes into both of these. So this is going to be negative 3, and let's see, 4 goes in there 13 times. So this right here would be the simplified answer. Again, if you left it like this, it wouldn't be the end of the world, but it does usually ask us to write it in standard form, which is going to be a plus bi. So we probably ought to write it like that. Let's take a look at the next one. We're going to multiply by the conjugate, so that's 1 minus 3i. So 1 minus 3i, so be careful on the top. Make sure you put that in parentheses. Okay, on the denominator, let's see what we end up with. This is going to be a 1 times 1, and then those middle ones are going to cancel each other out. You could write them down if you want to, and this is going to end up as a negative 9i squared. That's going to count as a plus 9. So the denominator on this one is going to be a 10. Let's figure out what the numerator is. So we multiply here and here. That's a 2 minus 6i. That's a minus 4i. And then this is a plus 12i squared. So this counts as a negative 12. So we'll put the 2 and the negative 12 together. So we're going to get negative 10. And then we're going to put the negative 6i and the negative 4i together. So that's going to be negative 10i. And again, I suppose you could leave it this way, but that would be really silly. That would be like leaving an answer like 10 over 10. We certainly wouldn't want to do that. So let's write it negative 10 over 10 minus 10i over 10. So this is going to be a negative 1 for the real part and a negative 1 for the imaginary part. So it's negative 1 minus I. We normally don't put the 1 in front there. And then we'll take a look at this guy right here. Similar type of problem, but this one doesn't involve i's. It just has a radical in it. So we're going to multiply by the conjugate. So that's going to be 2 plus radical 5, 2 plus radical 5. So in the denominator, let's see what we end up with. And I'll write this one out. We end up with a 4, because 2 times 2. We end up with plus 2 radical 5, minus 2 radical 5, and then I end up with minus radical 5 times radical 5. Well, those are going to cancel each other out. We're going to have a square root of 25 here, so that's going to count as a minus 5. And those two are going to cancel each other out. So take a look at what the denominator turns into. It's a 4 minus 5, so that's a negative 1. We'll take a look up here. We just distribute the 3 through, so this is going to be a 6 plus 3 radical 5. And we're dividing each one of those by 1. So if you want to, you could do 6 over negative 1 plus 3 over negative 1 radical 5. Either way, this is going to be a negative 6 minus 3 radical 5. And that right there would be our answer. Okay, I'm going to make this a little bit bigger and take a look at these last couple. This one says solve by taking square roots. So if we're going to take the square root here, and the reason we'd want to do that is because it's set up for that. So the first thing I'm going to do is I'm going to add 8 to both sides. So if I add 8 to both sides, I get this. I get a 49 here. Okay, so that's not too bad. And then I'm going to continue isolating this perfect square. I'm going to divide by 4. I find that much easier. We don't often have a perfect square as a coefficient in front, so we normally would get rid of that. So this is going to be m minus 5 quantity squared, and then I'd have a 49 over 4. So now we're going to take the square root. And like we were up above, we've got to put a plus or minus on here. So this is m minus 5 plus or minus square root of 49 is 7. Square root of 4 is 2. So I'm going to move the 5 over to the other side, and I end up with this. I end up with a 5 plus or minus 7 over 2. Okay? So you could write the answer like that, but if we're that close, if the numbers are that simple, let's just go ahead and write down that one of the answers is 5 plus 7 over 2, and then the other one is 5 minus 7 over 2. And if we get a common denominator, this is 10 halves. So I've got 10 halves. So it's going to be 10 halves plus 7 halves. That's going to be 17 halves. That's one of the answers. And 10 halves minus 7 halves, that's going to be 3 halves. So 3 halves is the other answer. Okay, so those are the two answers on that one. Pretty nice numbers on that one. This turns out to be kind of interesting. It's already isolated and all that sort of stuff. So we're just going to take the square root of both sides. This is going to be p plus 7. I'm going to immediately acknowledge the fact that I've got a square root of a negative. So I've got to simplify the square root of 27. That's going to be a 3 and a 3 and a 3. So I've got a p plus 7 equals, I'm going to take out a pair of 3s. So this is going to be a 3i radical 3. And don't forget the plus or minus on here. And move that over to the other side by subtracting 7. So here's what we get. We get p equals negative 7 plus or minus 3i radical 3. Okay, so there's the answer to that one. All right, let's take a look at the other side and see what fun we have for us there. We're going to solve each one by completing the square. We should be pretty good at this by now because we did the quadratic formula. So we'll take a look here. I'm going to save room to complete the square here by moving the 2 to the other side. So I have a 2x squared minus 3x equals negative 2. We're going to divide everything by 2, both sides, all the terms on both sides by 2. So I get an x squared minus 3 halves x. And over on the other side, this is just going to be a 1. Sorry, a negative 1 right there. Okay. And I'm going to take half that middle coefficient. So half of that middle coefficient would be negative 3/4. I'm going to hang on to that. We're going to square this. That's going to be 9/16. So we're going to add 9/16 to both sides. So let's see, this is a perfect square of x. Oops, I'm going to change colors back here. So this is going to be a perfect square of x and minus 3/4 quantity squared. And then this is, let's see, if I do 16ths, this is negative 16/16 plus 9/16. So that's going to be minus 7/16. And then I'm going to take the square root of both sides. So take the square root of both sides, and here's what I get. X minus 3/4 equals, this is going to be a plus or minus, and I've got a I on the top and a square root of 7, and then a square root of 16 on the bottom. So this is x minus 3/4 equals plus or minus I radical 7 over 4. So we've got a common denominator at least, that's nice. So I'm going to move this over by adding 3/4. Okay, do that on both sides. So this is going to be x equals 3/4 plus or minus I radical 7 over 4. If you want to leave it like that, I suppose that would be okay. You could also, because they already have a common denominator, you could write it like this, plus or minus I radical 7, all of that over 4. Either one of those is going to be fine, okay? And then we'll take a look at the next one. This one says solve by completing the square. So we need to move some things around here. I basically need to trade places with the two of these. So I'm going to add 8, and I'm going to subtract 4x. So this is going to give me 4x squared minus 4x. And then on the other side, we're going to have an 8. So on this one, let's see, I'm going to divide everything by 4. So that's going to give me, let's see, an x squared, a minus x, and on this side we're going to have a 2. Half of this would be negative 1/2. I'll do that in color here. So negative 1/2. I'm going to square that, so I'm going to be adding 1/4. Add 1/4 here. So here's what I end up with. I end up with x minus 1/2, quantity squared. And over on this side, if I do fourths here, that's going to be 8/4. So that's going to be 9/4 once I add that fourth. And then I'm going to take the square root of both sides. So let's see, I get x minus 1/2 equals, I'm going to have a plus or minus. This is going to be a 3 on the top and a 2 on the bottom because I take the square root. So I'm going to move that over by adding 1/2. So I get 1/2 plus or minus 3/2. This we definitely need to take care of. So one of them is 1/2 plus 3/2. The other one is 1/2 minus 3/2. So we end up with 4/2, which is a 2. And let's take a look at this one. This is going to be a negative 2 over 2, which is a negative 1. So the two answers are 2 and negative 1. Okay. All right, now we get to the problems where it's asking about the discriminant and stuff like that. So it says find the discriminant of each quadratic equation and state the number and the type of solution. So we're not solving anything here. We're just using the discriminant to describe the type of answers we get. So the discriminant, remember, is, whoops, not the whole thing. It's the b squared minus 4ac part. So this is a, this is b, this is c. So we're going to do b squared, so that's going to be 144 minus 4 times a times c. So that's going to be a 9, and that's going to be a 4. So if I were to throw that in a calculator, which I may in just a second, I think that's going to be 9 times 16. That's 144, so we end up with 0. So the determinant is, or sorry, the discriminant is 0. And what that means is we don't have the plus or minus portion, so we only get one real solution. Okay, so one real root or 0 or solution or whatever you want to call it. Okay, if we take a look at the next one, we need to move this around. So this is 3x squared. This is going to be a plus 9x. This is going to be a minus 2, and now it's set equal to 0. So there's our a, our b, and our c. So we're going to do b squared, so that's going to be 81 minus 4 times a times c. So a is 6, or sorry, a is 3, and c is negative 2. So when I multiply here, I get 81, and we're going to be adding something to this. So we're going to be adding, this is 24 times 2, so we're going to add 48. So if we add the two of those together, oh, take that back. I wrote down the wrong thing. This is a 3. Yep, sorry about that. So this is going to be, 20, there we go, 12 times 2. So this is going to be a 24. So we add those up and we end up with 105. Okay, so there's the value of the determinant. And the fact that it's positive means that we're going to get 2 real roots or 2 real solutions. Okay, however you want to say that. And then here's the last one. Again, a little bit of rearranging. 5x squared minus 2x. This is going to be a plus 4 equals 0. This is going to be, b squared is going to be a 4 minus 4 times a times c. So that's going to be a 5, and that's going to be a 4. So this is going to be 4 minus 80. So we end up with negative 76. So the value of the determinant is negative 76. The fact that this is negative means we're going to get 2 imaginary zeros. So again, I'm using a couple of different terms. I'm saying zeros, solutions, roots, all that sort of stuff, pretty much interchangeably. Okay, and then we'll take a look at these guys here. On this, it just says state the number of type of solutions and then state whether the discriminant is positive, negative, or 0. the fact that we have two zeros, two places where it crosses the x-axis, okay? So number and type, two real solutions, okay? And then the state whether the discriminant is positive, negative, or zero. That means the discriminant, okay, and I'll just abbreviate here, the discriminant will be positive, okay? So however you want to write that there. And then this guy right here, notice that it has number and type of solutions. It doesn't cross the x-axis here, so it doesn't have any real solutions, but remember, it's got to have two. So it's going to have two imaginary solutions, and that means that the value of the discriminant, okay, discriminant, let's say that's going to be negative, okay? And again, however you write that, as long as it's clear. And then we want to use the quadratic formula to solve these guys. So I'm going to zoom in on this so we've got some space on this. We might want to use a calculator, so we'll check and see here in just a second, see how these work out. So on this one right here, you'll notice that it's in the right order. So we've got an A, we've got a B, we've got a C. So we're going to write x equals, I like writing the big long fraction bar, and it's going to be opposite of B, so that's going to be -5, plus or minus. The b squared part, I normally handle that, so that's going to be 5 squared. And then this part, I never mess around with this. I always write down these things. So -4 times a, so that's -12, times c, that's a 2. And then the bottom is going to be 2 times -12, so that's going to be a -24. Okay, so I'm good with that right there. First thing I want to do is I want to figure out, am I going to be adding something or am I going to be subtracting something? So this is going to be a negative times a negative. So this is going to be 25 plus something. And that's going to be 48 times 2. So that's going to be, let's see, 48 times 2, that's going to be 96. Okay, so if I add those together, I think I end up with 121. But because this is a practice test and I want to make sure that I'm getting this right, I'm going to double check on my calculator. I'm going to type in 25 minus 4 times -12 times 2 and hit enter. We get 121, okay? So this is x equals -5 plus or minus the square root of 121 over -24. We recognize that as a perfect square of 11. So this is going to be x equals -5 plus or minus 11 over -24. And then we can probably write this as two separate pieces and see what happens. So one of them is going to be -5 plus 11 over -24. The other one is going to be -5 minus 11 over -24. So this is going to be, that's a minus 11 right there. We'll make sure that looks right. So this is going to be a 6 over -24, which reduces to -1/4. Okay, so we got our answer right there. That's one of them. And this one makes -16 over -24. And a negative divided by a negative is going to be a positive. And 8 goes into both of those. So this is going to be positive 2/3. So we got -1/4 and positive 2/3. We'll slide over here. I'll leave the calculator available if we need it. So this is in the right order. So we're going to do x equals, this is going to be a 4 plus or minus. I'll have a big square root here. And then let's see, b squared, that's going to be a 16, always going to be positive. And then -4 times a times c. So that's a 4 and a 7. And then it's all over 2a. So 2 times 4, this would be an 8. And then again, I check to make sure, am I going to be adding or am I going to be subtracting? This is going to be subtracting. So let's see, this is going to be 16 minus 16 times 7. That's a pretty big number. I'm just going to figure out what this is. So this is 16 minus 4 times 7. And we end up with -96. Okay, so it is negative because we're subtracting that big number here. So I get 4 plus or minus. This is going to be the square root of -96 all over 8. And I'm going to do a little bit of simplification here. So this is going to be 4 plus or minus. This is going to be I square root of 96 all over 8. And then 96 would be, let's see, that's going to be, what do we got here? I think that's 6 times 16. But let's just double check here. So if I have 96, that would be 2 and a 48. And that would be 2 and a 24. Yeah. Okay, so we're gonna get a bunch of stuff here. Okay. This is gonna be a 4 and a 6. Okay, so take a look right here. There's a pair of 2's, and that is another pair of 2's, okay? And the 6 is not going to break down anymore, give us any pairs. So here's what we end up with. We end up with 4 plus or minus. This is going to be 2 2's on the outside, so that's going to be a 4i and a radical 6 stuck underneath, and then that's all over 8. And then you'll notice something about these. These all have something in common. They all have a 4 in common. There's lots of different ways to handle this. I'm going to write this as 4 over 8 plus or minus 4i radical 6 over 8. And then we can cancel these. That's going to end up being a 1/2 right here. And that's going to cancel to be a 1 here. So that 4 will turn into a 1, and that 8 will turn into a 2. So I'm going to write it like this. This is going to be a 1/2 plus or minus I radical 6 over 2. Okay? Now, you could leave it like that. There wouldn't be any problem with that. You could also just do 1 plus or minus I radical 6 and then put all that over 2. Either way would be fine there. Both are okay. And then let's take a look. Last quadratic that we need to solve here. So let's get these on the correct side. So this is going to be x squared minus 14x, and then plus 19 equals 0. Hopefully this one works out nicely, but we'll see. So this is going to be x equals 14, because that's the opposite of b, plus or minus. And I might be grabbing a calculator on this one, because this is 14 squared minus 4 times a times c. And I'm going to put that in parentheses so I don't make a mistake there. And that's a negative 14. And let's see. So this is going to be a 1, and this is going to be a 19. And this is going to all be over 2. So we'll put a 2 right there. And then I'm going to do parentheses, negative 14 quantity squared minus 4 times 1 times 19. Could probably make this a little bit shorter, got all the signs right and stuff like that. So I end up with 120. This is 196 when we square 14, and then I'm going to subtract 4 times 19, end up with 120, okay? So this is, we've got an x equals 14 plus or minus square root of 120. So we know it's a positive number at least, and then that's all over 2. And 120, let's stop and think about this. 120 would be 4 times 30, and 30 is a 6 and a 5, and that's a 2 and a 3. So 30 doesn't simplify at all. So really what I've got here is I've got the square root of 4 times 30. That's a pair of 2's. So this is going to be x equals 14 plus or minus 2 radical 30 all over 2, which we can simplify this because we can divide both of those by 2. So I've got 14 over 2, and then I'll have a plus or minus 2 radical 30 over 2. And I can do some cancellation here. So once I cancel the 2's, and once I cancel the 2 with the 14, so here's what we end up with. We end up with a 7 plus or minus radical 30. Okay, so we got that right there. And then let's go full screen again, because I don't think I'm going to need the calculator again. Who knows, maybe I will. Let's see, we'll come down here, and we want to find the complex roots of each polynomial, okay? And then write in factored form. So if we could factor this, we're looking for two numbers that multiply to be 10 that combine to be negative 6. So 1 and 10 won't do it, 2 and 5 won't do it. So we're stuck using the quadratic formula. So we'll use the quadratic formula again here. So this is going to be x equals, this is going to be 6 plus or minus, then we'll have that big square root. This is going to be a 36. And minus 4 times a times c. So that's going to be a 1, and that's going to be a 10. And then this is all over 2. So I get a 6 plus or minus 36, and I'm going to be subtracting something. That's 40. So this is a negative 4. Okay, so square root of negative 4 all over 2. So this is going to be, let's see, 6 plus or minus square root of negative 4 is going to be a 2i over 2. So here are the two zeros. I get 6 over 2 plus or minus 2 over 2i. So that's going to be 3 and then plus or minus I. Okay, so one of the zeros is x equals 3 plus I, and then the other zero is x equals 3 minus I. So if I just make the factors out of these, I basically just move these to the other side to set them equal to 0. So this is going to be x minus 3 minus I. And when I move that over, it's going to be x minus 3, and then minus a minus I is a plus I. So I get a plus I right here, and then I factored that quadratic. Okay, this one's a little bit more interesting, and I think we can do this a little bit more quickly. That's a perfect square of x, and that's a perfect square of 25. Sorry, perfect square of x squared. So this is a difference of squares here. So this factors to x squared minus 25, and the other one would be x squared plus 25. So this one's pretty easy. We can factor that all day long. That's just a difference of squares, perfect square of x and perfect square of 5. So this is going to be x minus 5, and the other factor for that would be x plus 5. And then for this one, you may have caught on to this, but I'm going to take this over here, and I'm going to say x squared plus 25 equals 0. I'm going to find the zeros for this in order to factor it. So I'm going to subtract 25 from both sides, and I get x squared equals negative 25. And I'm going to take the square root of both sides. So I end up with x equals plus or minus, and square root of a negative, that have an I in it. So here are the two that I get. I get x equals 5, and 5i, and I get x equals negative 5i. So x equals negative 5i. Well, again, if I just move those over, I'm going to get two factors here. One of them is going to be x minus 5i, and the other one for this one right here is going to be x plus 5i. All right, so I put a box around that, and I call it good. And we're done. Good luck on the test.